The focus on this video is using ratio tables to start making comparisons, and you'll need a good understanding of equivalent ratios to solve these types of problems. We'll go through two problems as an example. This first problem, create four equivalent ratios, 2 by scaling up, 2 by scaling down, using the ratio 30 to 80. Finding equivalent ratios is not altogether very difficult. It's most common to think about equivalent ratios by scaling up. When we scale down, however, you just need to adjust your thinking and think, okay, instead of multiplying each side, or if you're thinking as a fraction, multiplying the numerator and the denominator by a common number, we could divide each of these. So if you look at both of these numbers, well, they both end in zeros, which means it's pretty simple to scale down. We can think about dividing it by 10. And we can do the same thing to both sides. 30 divided by 10 would be 3. 80 divided by 10 is 8. So there's an example of that ratio scaling down would be 3 to 8. We could do the same thing dividing it by 5. We could divide it by 2. If we divide it by 2, it would be 15 to 40 ratio. And that would be an example of scaling down as well. And you could see, looking in your ratio table, it would be simple to scale down by actually looking at the 3 to 8 ratio and scaling this up, because 3 to 8 is the simplest form. So you could have taken 3 multiplied by 2, you would have gotten 6. 8 times 2 is 16, so 6 to 16 would be another. 15 to 40, and so on. If we want to do scaling up, well, we could multiply both of those by 2, or whatever number we want to. So it would be 60 to 160. We could multiply them each by 10 or 5 or 100. We'll make it simple and make it 300 to 800. So this altogether is not a very difficult concept. It's useful when we start moving into the next task, which is starting to compare ratios that don't show that common relationship. An example of this is the next problem, which says use the ratio tables to determine who the faster swimmer is. At top we see Sarah, and it gives the distance she swims in meters over different time periods. It shows how far she swims after 3 minutes, 5 minutes, 12 minutes, 17 minutes. Same thing with Eva, but her times are 2 minutes, 7 minutes, 10 minutes, and 20 minutes. So when you get a question like this and we need to determine who the faster swimmer is, well, we can see that if we look at this first ratio, 3 to 75 to 2 minutes to 52 meters, well, Sarah's swimming a further distance. So one's first inclination might be to think that Sarah's faster, she's going 75 meters, but she's also spending an extra minute swimming, which makes this comparison a little bit different. We need to find a way so that we can find a common relationship between their time and the distance, and this table doesn't give us that information. However, you can start thinking there are some ways to do it. If we look at this first piece of information, 3 minutes to 75 meters versus 2 minutes to 52 meters, well, how can we get these to be a common amount of time to make a comparison? You might think, okay, we can make this 6 minutes by multiplying by 2 or doubling it, and if we make it 6 minutes, then it would be 150 meters. So we can think of it as a 6 to 150 ratio. And if we look down at Eva, if we wanted to get it to 6 minutes, so we can make a comparison, we would have to multiply by 3 to do that. So we would multiply 52 times 3 as well, and that would be, was that 156? Okay, so now we have a common piece of information, so that when we make a claim, now we have some evidence. So I can make the claim that Eva is the faster swimmer, because if they both swam at a common period of time, it's 6 minutes, Sarah would travel 150 meters, and Eva would travel 6 more meters, 156 meters. Another way to get evidence, and there are a whole lot of ways, this Eva tells us in 10 minutes she goes 260 meters, and we could find how far Sarah would go, and we wouldn't need to convert anything for Eva. We could just go straight to multiply each of these by 2 or double it, and we would find 10 minutes to 250 meters. So now we have a common basis to make a comparison that Eva is faster. And that's pretty important with ratios. And when we talk about fractions, we would call this either a common denominator or a numerator, so we can start to make that conclusion.